right, so thank you so much for clicking this link and for watching this video. This is GBank's mathematics, and it's solely mathematics questions for senior high and junior high school students. Okay, for today we have WASSCE PC Series 2, which is the second series, popularly known as the NOBDEC 2025 questions for elective maths, question number 11B. To get the rest of the questions, please follow my handle. You realize or you find the question 1 through to the rest of the questions in the profile, right? So with this one, we are supposed to solve for the value of x, where x is an integer. First, we need to note that an integer is positive and then negative whole numbers. The key term is whole numbers, including 0. So positive and negative whole numbers including 0. That is an integer. All right. So let's solve this question quickly. We have 3 root 4x minus 3 minus the square root of 5x plus 1. And this gives us 5. Always solving set or radical equations, we maintain one set at the left-hand side and then move the rest to the right-hand side. Okay, so let's look at this. We are maintaining 3 root 4x minus 3. So this becomes 5 plus the square root of 5x plus 1. Then the next thing to do is to square both sides so that we do away with the radical at the left-hand side. So squaring both sides, I have 4x minus 3 all squared, and this gives me 5 plus the square root of 5x plus 1 all squared. So this gives me 9 multiplying 4x minus 3 at the left-hand side. Then the right-hand side, after the simplification, gives me 25 plus 10 root 5x plus 1, and then plus 5x plus 1 again. All right, so let's simplify what we have on the left and then the right hand side. This gives me 36x minus 27 when I expand the bracket. Then this gives me 26 plus 5x and then plus 10 root 5x plus 1. Now I need to group everything, leaving the radical at one side of the equation. Okay, so I'm going to group everything and leave the radical at the right hand side of the equation. I'm going to get 36x minus 5x, then negative 27 minus 26, and this gives me 10 root 5x plus 1. So simplifying the left hand side, I have 31x minus 53, and this gives me 10 root 5x plus 1. Then to do away with the radical again, just as we did for the first one, we are going to square both sides, right? So I have 31x minus 5 or 53 all squared, and this gives me 10 root 5x plus 1 all squared. So expanding the left hand side and then simplifying it, that gives me 961x squared minus 3286x, then plus I have 2809, and this gives me I have 100 multiplying 5x plus 1 when I expand the right hand side. So I need to expand this as well, which gives me 916x squared minus 3286x plus 2809. This gives me 500x plus 100. So looking at what we have here, we are surely going to solve quadratic equation. Okay, so meaning we group everything, equating everything to 0. So I have 961x squared minus 3286x, then minus 500x. I'm grouping them straightforward. I have 2809 minus 100, and this gives me 0. So 961 x squared minus, this is going to be negative 3786x, then plus 2709, and this is equal to 0. So finding the factors, when we solve this and then get the factors, our factors is going to be x minus 3, and then we're also going to get 961x minus 903, and this is equal to 0. When we solve this quadratic, we are going to end up getting these factors. When I pick the first factor, x minus 3 equals 0, x gives me positive 3, and then when I pick my 961x minus 903 equals 0, I'm going to get x equals 903 divided by 961. And then we go back to the condition. They're saying where x is an integer, all right? So between the two, we know that an integer is a positive or negative whole number, including 0, all right? So let's see, this tells us that our value for x is going to be 3. So thank you so much for watching. If you have any comments, please go to the comment section, ask your questions. I'm going to get back to you and then respond adequately. You can follow my link to see the rest of the solutions to the rest of the questions. And then please support by liking and sharing for more videos. Thank you. This is G Banks Mathematics. Bye-bye.